So this is Brandon McCollam. He's from the University of Chicago, and he's been coding in Python for well over 5 to 10 years. And he's going to give us a talk about OAuth today. Let's go ahead and give him a round of applause.
Hi, thanks for coming to my talk, everyone. Just to start off with a little bit about myself, I'm originally from Chicago, but I moved to London about a year ago, so living there now. I work at Globus. We're a nonprofit. We're a joint project between the University of Chicago and Argonne National Lab. We're a data platform that helps manage large-scale scientific data, and I work on the authentication backend for that using OAuth2 and OpenIDConnect, two protocols that we're going to be talking about today. So what do I mean by those? What are we actually talking about? If you've ever logged into a website using some other account, Facebook, Google, maybe Twitter, you have probably used these protocols without necessarily even being aware of it. Different people have different terms for this. Some people call this single sign-on. Some people call this federated identity. Some people get really pedantic about the distinctions between those and will fight you if you use the wrong word. So I'm kind of sidestepping that. I'm calling this whole scheme web identity. So basically any situation where you have a user that wants to log into a website, but that website doesn't want to do the authentication itself. So they're going to redirect the user over to some third-party authorization service. The user can log in there, and then they get redirected back to the website as an authenticated user. So why would you want that? Why does anyone care about this? So a big part is going to be convenience. So users have lots of accounts these days. Users don't like signing up for new accounts, especially if you have a small website. Maybe you're running a hobby project or a little app that you're trying to get off the ground. Users might not want to sign up for yet another account. So it's more convenient if they can just use an account that they already have and log into your application. Access to a third-party platform can be a big advantage of using remote authentication like this. So if you have some kind of professional application, maybe you let users log in with their LinkedIn account, and then you get access to their LinkedIn contacts. So you want to be careful about the privacy implications of that, but it can be a real advantage for your application. Security is a big win here, so especially if you're just starting out and you don't want to have to deal with all of the security implications of managing users' passwords, securing password hashes, using salts, setting up two-factor authentication, having a secure way to recover a lost password. Like, these are all hassles to deal with, and if you can offload that to somebody like Google or somebody like Facebook, somebody who's got deep pockets and a security engineering team and intrusion detection, that's a big win for you as a developer and for your users who don't have their credentials stolen. And finally, just sheer laziness. As a developer, anything that we can do that can be somebody else's problem, if you can use a library, if you can avoid repeating yourself, if you can avoid reinventing the wheel, that's great. So if you can let somebody else handle authentication for you, then it's one less thing on your plate. So I know I said I wasn't going to be pedantic about terminology, but there is one distinction that I want to draw here that I think will help make it easier to understand as we go forward. So I want to talk about the difference between an authorization protocol like the OAuth series of protocols and authentication protocols like the OpenIDConnect and OpenID protocols. So when you're talking about authorization, you're talking about something that gives you, the client, permission to do something. So it is authorizing you to do something. So you can think of this as analogous to a key that unlocks a door, it unlocks something. It might give you access to calendar entries. It might give you access to upload files to a cloud storage solution. It might give you access to read from or post to social media. But the important thing is that the key itself doesn't have informational content. So the key doesn't tell you anything about the owner of the key or the person that key belongs to on its own. In contrast, an authentication protocol, you can think of authentication as analogous to an ID badge. Maybe an employee ID badge would say something like the person's name, what department they work for, maybe when it expires. So the other thing that is important to mention here is that these various different protocols are not backward compatible with one another. So this is a really important thing to get across. When I first started learning about this stuff, I wasted a lot of time going down rabbit holes, reading about the wrong thing, because you think, well, I'm going to Google for OAuth and I get OAuth1 results that aren't applicable to OAuth2, or if you're reading about OpenID2, that document isn't necessarily going to help you implement OpenIDConnect. So really, it's important to know that other than the fact that the names are similar, like these protocols have basically nothing to do with one another. I mean, they accomplish similar goals, but they in terms of implementation, they're completely different. But there is one thing there is related, OpenIDConnect and OAuth2, the ones that we're talking about here. So OpenIDConnect, in fact, is an extension of OAuth2. So any OpenIDConnect server is also an OAuth2 server. So an OpenIDConnect is a strict superset of OAuth2. So what does OAuth2 do for us? It basically answers the question of how do you let users log in without seeing their passwords. There's a specification or a document for this, RFC 6749, so you can go look it up and read it. It defines some concepts. It defines an access token, which is, in this analogy, is plays the role of our key. So it's just an opaque piece of text that lets you do things. And then it also defines the concept of a scope. So a scope you can think of as a unit of permission, or what the key unlocks. So there might be different authorization providers define their own scopes, and your client that you write can request those scopes. So you might request access to a user's contacts or their calendar, or whatever else the authorization provider offers. And that's the scope is what you can do with the access token. The other thing to know is that the RFC is more of a framework than a specification. So it lays out kind of in broad terms how to accomplish this goal, but it leaves a lot of details up to individual implementers, which is actually kind of frustrating because it means that no two OAuth2 implementations are necessarily compatible with one another. So if you have a client that works to log into Twitter, you can't just use it unmodified to log in via Google or using Globus. There's always going to be some configuration that you have to do. There's always going to be little changes that you have to make, and you're always going to wind up having to read the documentation from the authorization provider that you want to work with. Nevertheless, despite that drawback, OAuth2 has had wide adoption. It's kind of the de facto standard for web login these days. Almost all of the big web properties support it. And the advantage of that is that there are nice Python libraries out there for it, especially on the client side. So a lot of these implementation details and kind of irritating things you don't have to worry about so much. The library will take care of it for you. So the main flow in OAuth2 is what's called the authorization code grant. So this is how we log in a user without seeing their password. So the user agent, which is the user's browser, is going to say, I want to log in. So it makes a GET request to the client. So the client in this case is your application. So you as developers will write a web application that's a client. So this would be a server-side web application. So you're going to say, oh, actually, we don't do authentication or authorization ourselves here. We're returning a redirect, and we'd like you to follow that over to the authorization server. And as part of that redirect URL, you're going to include a scope that your client is requesting, one or more scopes, and then also a client ID. So when you register your application with an authorization provider, they'll give you a client ID and client secret, and you'll pass that client ID along with your authorization request. So the user's going to log in. How that happens is not your problem and you don't care, but assuming that they succeed in logging in, then the authorization server is going to return another redirect, and that redirect in the query parameters is going to include a secret code, and this is called the authorization code. You can kind of think of this as like a one-time use password. So the user's browser, the user agent, is again going to follow that redirect, and it's going to come back to your client application on the callback URL. So this is a URL that lives on your application, you define it, but you'll give it to the authorization server when you register so that the authorization server knows that it's a legitimate URL to redirect the user back to. So the user arrives back at your client at the callback URL with their authorization code in hand, your client is going to grab that authorization code, and then it's going to turn around and post that to the authorization server. And this post is also authenticated with your client ID and client secret for your application. So the authorization server can validate that this is a legitimate application using this code. And then assuming that that is all good, it returns a JSON document that includes, among other things, the access token. So finally, you have your key in hand, and you can use that in an HTTP authorization header, so you can make other requests to protected resources, and you can say, here's my key, let me in, let me have access to that. There's a bunch of other stuff in OAuth2 beyond that. If you need long-term access, there's such a thing as a refresh token. So access tokens expire, but you can keep getting new access tokens by using a refresh token. If you have a public client, so like a JavaScript client or an installed, maybe a mobile application or a desktop application that can't keep a secret, there's another less secure flow that you can use for that. There's a client credentials grant if you're, instead of getting a token for a user, if you need an access token that belongs to your application itself, you can do that. The spec also defines a username password grant, I guess just for legacy compatibility. And it defines ways to build extensions on the OAuth2 framework. So if you work in academia, you might be familiar with SAML, which I think is Security Assertion Markup Language. It's an XML-based authentication protocol. So there's an extension to OAuth2 that kind of allows interoperability between a SAML universe and an OAuth2 authentication universe. And OpenIDConnect itself is actually an extension to OAuth2. So it's actually a series of extensions. And the point of OpenIDConnect is to add the missing authentication layer on top of OAuth2. So remember, we talked about the distinction between authorization and authentication. So OpenIDConnect will give you metadata about the user. So instead of just having a key, you'll know something about who this user is. And the way that you enable that is if you are talking to an authorization server that you know is actually an authentication server, it's an OpenIDConnect server, you pass a special scope, which is OpenID, and that triggers the flow to say, I want this to be an OpenIDConnect flow. And what that means is that in addition to the access token, you also get back an ID token. This is a JSON web token. Some people might be familiar with that. It's basically just an encoded JSON document that is cryptographically signed. And if you decode it, it contains these claims, which are metadata about the user. It might be like the user's name or their email address or perhaps their postal address or basically whatever the authentication server feels like. So different authentication servers have different information about their users and different claims that they can return to you. OK, so that's kind of the basic layout. So let's look at what this looks like in practice. So this is our kind of toy application for this demo. Don't worry too much about the details of this. We're using Flask, which is a Python micro framework some people here might be familiar with, or if you've used Django or Pyramid, it's basically a similar idea. So that's going to handle routing and give us a request object and a session object that we can save things to. So this is kind of a standard database username password login. We're going to look at this login post method here. So some people here might have a method like this already in their application. So the user submits a form as a HTTP post. You grab their username from the form, look up that user in the database. You check their password. We're using the bcrypt algorithm to verify that the user's password matches the password hash that we have stored. So we've been careful and not saved any clear text passwords in our database because we treat user security seriously. Assuming that that validates, we set the user as logged in our session and return to the main page. Otherwise, we return a login error. So if we want to replace that kind of a login flow with an OAuth2-based login system, we're going to use this library, requests OAuthLib. This is a nice high-level client library. It uses another library, OAuthLib, and requests under the hood. And we need to get some configuration parameters. So you need your client ID and your client secret that I mentioned when you register your application with your authorization provider. They'll give you those. You need an auth URL, a token URL. So the auth URL is the URL that we're going to send the user to go log in. The token URL is the URL that we're going to be posting to Exchange. When we do that swap of the authorization code for the access token, the token URL is where we're making that post. And then the scope is going to be whatever scope we want to request for our application. And the redirect URL, or URI, this is the client's application's URL that is going to handle those requests when they come back from the authorization provider. So here's what the login method would look like. We instantiate this OAuth2 session object, so we make a provider. We pass in our client ID, we pass in our scope, we pass in our redirect URI, and it's going. Then we're going to call this authorization URL. We pass the base URL, and it will populate this with all the query parameters that we need, and it's going to return us a URL and also a state parameter. So this state parameter, we just hang on to, and that's going to be used to prevent cross-site scripting attacks. So we want to be able to double check that when the user comes back to our callback URL, that we actually sent them out. It's not, somebody else, a malicious attacker sending that request in. So then we redirect the user. We say, okay, goodbye, go off to the authorization provider. We'll see you later. And then this is our callback method. So after they've logged in, this is the redirect coming back from the authorization provider. So it looks kind of similar. We again instantiate a provider object from this OAuth2 session. And we pass in our state parameter that we had saved, and it's going to validate that for us. We call this fetch token method. So in the background, what this is doing is grabbing the authorization code out of the query parameters. So you see we passed in request.url. So it's grabbing the authorization code, and it's making that authenticated post in the background. And it's going to, assuming that the code is valid and our client credentials are valid, it's going to return a successful token response, which contains our access token. And it also contains some other nice things like the expiration time of our token, which we might want to hold on to. And then if we want to use that token to make other requests, so this is just an API URL for a protected resource. So this is our transfer API. So you can use it directly. The provider, you can call just provider.get, and since we just got that token, it'll just automatically use it for you. So that's kind of convenient. But if you don't have that provider handy, let's say you redirect to another method. Now we have our access token, so we're logged in. It's not that hard to sort of manually use this token. So all you do is set an authorization header. So you do authorization bearer and then your access token, and then we're just using request.get and passing that as an authorization header, and so that'll get us the same result. And so that's how you use the access token that you've gotten back. So obviously, we don't know anything about our user yet. We just have this sort of anonymous token now. So if we wanted to add OpenIDConnect on top of that so that we actually learn something about who this user is, we're just going to need to import a few more libraries here. We're using system random just to generate cryptographically random data. And then we're using this Python Jose JWT library. So as I mentioned, the ID token is a JWT, so we want to use a JWT library to manipulate that. The JWT is signed, so we go ahead and grab the public keys from our authentication provider, and we just hang on to those. The scopes here, we're requesting different scopes. So we're requesting the OpenID scope to signal that, yes, we want this to be an OpenIDConnect flow. And we're also requesting the email scope, which is saying I'd like to have the email claim in our ID token. And then the profile scope just says, yes, I'd like some other metadata about this user. Different authentication providers have different ideas about what counts as profile information. So you have to read the docs. The issuer is who do we expect is going to be signing the ID token, and then the algorithm is the algorithm that the token will be signed with. So that will all be available from the docs from your authentication provider. So this is the login method. You notice this looks very, very similar. The only real difference is that we're now generating this random nonce parameter, and we're passing that along with our authorization URL. We're holding on to that. So it's kind of similar to the state parameter. It's to prevent replay attacks or cross-site scripting attacks. So it basically, we're going to validate that, and it's going to come back in the ID token you'll see on the callback URL. So this is the callback method. It looks a little longer than the one that we saw for OAuth2, but actually the top half of this is all the same. So we're only going to look at the bottom half of this that is the new stuff for OpenIDConnect. So everything above that was the same as from OAuth2. So as I mentioned, alongside our ID or our access token, the response now contains an ID token. We're going to decode that using this jwt.decode method. We pass in the ID token. We pass in the public key we expect it to be signed with. The issuer, the audience here is ourselves. So we pass our own client ID. We expect this ID token will be issued with an audience for us. We pass in the algorithm. We pass in actually the access token that we got back as well. So it validates that this access token and this ID token go together, that they came back as part of the same authentication flow. And then we also want to assert that the nonce parameter that we saved in our session is the same as the nonce that's in the claims that from our decoded token. And assuming that that's all good, then we now have the information that we wanted about the user. So the subclaim is for subject, so that's basically just a user ID. It's what the authentication provider identifies that user as. We can get their email because we asked for the email provider, and we get their name, and we can redirect to the home page. So that's pretty much what a client implementation looks like. If you're doing a server implementation, unfortunately there are fewer libraries out there. There's OAuth2, which is a little bit more mature. There's PyOIDC, which looks very promising but is new and doesn't have as good of documentation. Some things you need to think about. All of the authentication problems that you offloaded as a client, you now need to consider if you're going to be a server. So password resets, two-factor authentication, password hashing, all that stuff. How are you going to get consent from your users, and how are you going to provide your users a way to revoke that consent if they don't want to share data with a third party anymore? And then thinking about the token format. So the ID token format is already specified for you by the OpenIDConnect specification. But for the OAuth2 tokens, the access tokens, those are just opaque strings, and they can be whatever you want. So you can think about, do I want to have to look that up in my database every time? Do I want to include a signature in that so I can validate it cryptographically without talking to the database? How do I want to handle revocation of tokens? So things to think about. If you want to come talk to me afterwards about server implementations, I have thoughts. So that's pretty much it. If anyone has any questions, please come forward. And the slides and all of the code examples are up on my website. Globus, we're actually hiring if you want to work for a university and help contribute to science, globus.org/jobs, and there's some links to useful libraries that we talked about or used today, and also the Globus SDK, which is kind of a higher level. If you only want to interact with Globus APIs, you don't even have to really think about any of these details. We have a library that will handle that for you. So.
Yeah, it was a nice talk. So I'm assuming, can we do OpenIDConnect for APIs?
I'm sorry, I didn't quite catch that. You're asking about something about Active Directory, is that right?
No. Can we do OpenIDConnect for APIs, REST APIs or something?
Yeah, absolutely. So you're going to be it works really well with REST APIs because you're passing the access token in the authorization header. So if you're making a GET request or a POST request, so any kind of REST API, you can authenticate that via OAuth2. So you would just, if you were setting up a server, you'd need to have a way to validate those tokens. So your authorization provider will tell you, either they'll say, hey, send a token to us and we'll tell you whether it's valid or not, or they'll say, our tokens are signed with this, and you can check cryptographically that it's a valid token. So if you basically would just develop your REST API so that you inspect the authorization headers, look for the token, and then validate that that token is legitimate before granting access.
OK, thank you.
Okay.
Sorry.
Yep.
Just a quick question. Provided that you can't use like a big social network or something like that as your provider, you have a business clients or something like that where you're wanting to maybe brand it as your own. Is there any particular thing that you want to look for in a third-party provider if you don't want to do your own solution? For the actual authorization and authentication that they've done in their implementation that would be a better thing to evaluate them with?
That's an interesting question. I guess I would sort of ask them questions about kind of how they handle user data, how they handle user security. So things like, what's the lifetime of their tokens? Do they publish their public keys? So one thing that I didn't really mention is all of that stuff about signing and validating the ID token is kind of semi-optional, because you're going to be receiving that information over an SSL connection. So assuming that connection is secure and that the server certificates are legitimate, you can kind of get away without doing that, but it's always best practice to kind of belt and braces solutions. So I would maybe ask them questions about how seriously, what do they provide for validating ID tokens? Do they rotate their keys? So those are kind of questions that I think would be generally indicative of how they handle security. And then how good is their documentation? What's their uptime like? I mean, if you're gonna rely on them for your login solution, and if they go down, then none of your users can get into your system. Then I think separate from how seriously is their security, how serious is their ops? Are they going to be there when you need them? So those are questions that I would ask.
Thank you.
Hi, thanks for the great talk. I was wondering if you had thoughts on requiring servers or authorization services to use secure enclaves when they're trying to authenticate your tokens that people log into.
So when you say secure, you mean SSL, TLS secured, or?
Like the enclave security in processors, where it has to have signed computations and can't be kind of hacked in case these services are running on VMs or stuff like that.
Yeah, I'm not really that familiar with that myself. So one of the advantages of OAuth2 is kind of its basic simplicity, that the tokens themselves are bearer tokens. So anyone who has that token has that permission. So there have been attempts to enhance the security of that. So I think there's MAC signed tokens. So maybe that's what you're getting at. There are attempts to kind of harden that more, but I haven't used them myself, and I don't think they have really wide adoption. I think people, one of the reasons OAuth2 is more popular than OAuth1 is that OAuth1 had its own extra signing protocols and things, and it proved difficult and complicated for people to implement. And so I think in kind of a narrow scenario where you knew all the parties involved and you were building both sides of the system, then yeah, I think some of those other things would add security, but I don't think you'll see that many of them on the open internet in the wild yet.
Okay, thank you.
Maybe
let's go ahead and call it good there. And if you have any more questions, feel free to talk to him afterwards. So now we'll break for lunch. Thanks, everybody.
Yep. Thank you.